Welcome to the SUSE Exchange and this session on Accelerate and creating faster time to production across your data centers, cloud, and edge with SUSE. So what is SUSE Accelerate? Actually, let me introduce myself. So I am Mark Abrams. I am a domain solution architect here at SUSE. I came to SUSE through our Rancher Labs acquisition. Rancher Labs was a company and had products around cloud native technologies, specifically Kubernetes. And we have been working closely since joining SUSE and before joining SUSE, but SUSE really helped us accelerate our business. Basically, together we've kind of built this edge product that Rancher had started and SUSE had started kind of pieces of it, and together we've built this awesome solution. So that's really what I want to talk to you about today. So with that, so SUSE solutions can help you achieve more faster. Using SUSE can not only assist in deploying applications, but we can do this at scale over any infrastructure. Need to push out a feature update to 500 plus Kubernetes clusters. Urgently need a patch or a security vulnerability gets exposed in your apps affecting all your public cloud deployments. What about deploying hundreds of devices in multiple locations across the globe? SUSE can do all of this, and we've got you covered. Complicated edge deployments can be a thing of the past. We can ensure that your devices running key business or analytical applications are running at their best, meaning less time worrying about data in transit to a central location. With all the features and tools SUSE provides, we decrease your time to production, meaning, of course, faster time to value. Keeping not only your executive stakeholders happy, but also the engineers and operators that have to deploy and maintain your applications and systems. The technologies we develop at SUSE can help accelerate deployments across any computing infrastructure. In order to provide you with a coherent understanding of how our technology stack is used to accelerate business, I'm going to focus on the computing referred to as edge. I like this domain as an example because it exposes requirements and features of all computing operations, but in data center operations, we often take for granted the innovations which have developed over the last 25 years. Edge is often one of the largest scale deployments for a business and often one of the most complex. Data centers, of course, are homogeneous, secured, well-staffed, climate controlled, and as a result, they are much easier to develop solutions into. Edge compute is typically heterogeneous, sometimes in harsh environments, lacking physical security, run by operational technologists, and often bandwidth constrained. With that foundation, let's have a look at how SUSE accelerates business at the edge. So first of all, let me clarify what we mean when we say edge at SUSE. There are many different industries which do edge computing. At SUSE, we've divided edge into three primary areas to cover the vast landscape which these use cases fall into, and it's very large. So we're going to try and scope it down for the conversation today. Near edge is generally the realm of communication service providers. As with any domain, this use case has unique requirements. In some ways, it's the most like a conventional data center, but it absolutely falls into the edge category. Our recently released adaptive telco infrastructure platform is designed to excel at meeting these communication provider needs. The far edge is typically located at the outer edge of the network. In some cases, it is an enterprise app installed in someone else's data center. In other cases, it is an isolated unit at the edge of the network, like a retail store, a factory, or a mobile environment like a vessel or a truck. In some of these cases, there are rack-mounted servers, and in others, the compute consists of desktop-class machines. SUSE is an innovator for the far edge. We have developed an open source full stack management solution for the edge at scale. When I talk about at scale, I'm referring to use cases where there are deployments at the magnitude of hundreds to tens of thousands of devices sitting in physically different locations. Contrast this to a large data center where resources are centralized. So an AWS or a Google may also have hundreds to tens of thousands of devices, but they're all centrally located and managed, or across just a few data centers, as opposed to deploying out to the thousands or tens of thousands of data centers, which is what your edge becomes. Finally, let's talk about the tiny edge, that little bit on the far right there. Tiny edge is the ecosystem of industrial IoT. These devices tend to be too small to run Linux and Kubernetes. They often have a dependency on far edge or cloud systems. Sometimes they have a dependency on near edge. Broadly, we can say that these are sensors and actuators. Things like temperature, humidity, cameras, and motor controllers fall into this category. As you can see, the further out we go toward the tiny edge, the greater the number of disparate devices. Traditionally, the tiny edge is a network of independent things communicating over standard protocols. Excuse me, I'm going to get a little sip of water here. So the tiny edge typically is independent network of things communicating over standard protocols, but in a complex network. So these could be mesh networks. They have various channels for communication. They're not all using TCP/IP like us humans do for how we get our information, data, access the network, right? SUSE is bringing together cloud-native technologies and the tiny edge. In a cloud-native world, every sensor and actuator is a potential resource. And what better technology to manage resources than Kubernetes, which is all about resource management. The SUSE Edge solution is leading the way to bring millions of these industrial IoT devices into the cloud-native ecosystem with our Edge stack. Now, most enterprises have some edge compute, but let's go beyond the little deployments here and there and take a look at large-scale deployments at the edge. Let's talk about retail. This is a good area because it captures a lot of the capability while giving you sort of a place to stand on, right? We all know something about retail, and so it's kind of very visceral, and you know, many of you have heard the stories of some of the current retail outlets and food chains and the way they're running their operations using Kubernetes. And so it's really a nice place to talk about edge because it's just a very obvious location, and we've done quite a bit in this space. You know, of course, retail has been using compute in the stores for years now. For a while, the credit card machine was probably the most advanced technology in a retail store. And then retail stores began using computers to manage point of sale systems, inventory, and more things. Eventually, retailers began connecting the stores with back-end systems in the data center, or eventually connecting with the cloud once cloud came about. These technological advancements helped retailers manage large numbers of stores more efficiently than ever before. However, today, this is considered an outdated process model. Let's look at a few of the devices inside today's retail store. Of course, there's a computer or computers which reside on an in-store network. The network, of course, needs to have a router and possibly some sort of DHCP server to manage multiple device IP addresses within the facility. There would be, of course, the point of sale, the ordering system, the inventory management, which they've had for years now. Stores today also have cameras, and I have talked to retail stores that have, like tens of cameras, like 50 cameras in a single store, and then thousands of stores. And they may have a variety of industrial IoT systems, like things like smart lockers, smart ovens, smart fryers, of course, scanners, printers, right? So there's a whole bunch, and depending on your business, the retail outlet has quite a lot of technology going on. On each of these hardware components, whether it's computers to cameras, there's some type of software that drives it. And the core computer systems will have multiple applications to be used by clerks, by staff, by managers within the store. So there is a lot going on. And I don't think anybody would deny that there is a lot of compute and systems going on in a retail operation today. So with an understanding of what's in the store and what makes it run, let's scale it up, right? So that's what the retailers are doing. And at SUSE, we see the number of stores range anywhere from tens to tens of thousands. Due to there being so many stores, so many applications and devices, the modernization of stores without automating the process can be extremely difficult and error-prone. This is only complicated by business models like a franchise, where owners actually have more control over when and what hardware they use or update. So the more that an enterprise can gain control over these remote resources, the better off they'll be, the better they'll be able to accelerate their business and get done what needs to be done to really bring a retail outlet to functioning capacity in a modern world. So as I said, I'm using retail as an example because of it covers so much. But the challenges of scope and scale, they really touch every industry that operates at the edge. Technology is getting more complicated, and at the same time, the workforce within edge business, whether in retail, healthcare, manufacturing, whatever industry, they're trained as end users of the end products, not as technical resources who can fix a broken computer. These end users are operational technologists, OT. In order to truly support operational technologists, the products they use must not only be stable and robust, but also easy to set up and configure should problems arise, or just so that we can reduce the impact on the people that have to do the work. SUSE has been working on bringing cloud-native technologies to the edge as a way to serve these operational technologists. Excuse me, another sip of water here. At the same time, we're helping accelerate an enterprise's production and longevity of these operational technology solutions. So why would you want your edge compute to be cloud native? Shouldn't it be in the cloud? Well, some of the features of cloud native include reliability, availability, scalability, and resource scheduling. In addition, the SUSE Cloud Native ecosystem allows an enterprise to remotely manage and monitor your systems easily. While not every business at the edge is going to take advantage of all cloud native aspects, there are clear gains to utilizing as much of the cloud native methodologies as will fit the business process and needs. SUSE has a really proud portfolio of technology to help accelerate these edge deployments. And we also have the experience and know-how to enhance an edge solution to fit whatever industry you're in. This is just a sampling of the cloud native edge management stack. This page is an example of technology which might be used in the retail stack. By using these technologies, you can accelerate edge deployments, not only at the hardware level, but also reducing time to production, which is how we got started, right? Using workload management and monitoring. we can help you transform from a legacy bare metal or virtual machine stack in a retail environment or in an edge environment to a modern cloud native model, which can be bimodal. This can reduce the impact of bringing advanced technology on site while maintaining the long tail of your legacy edge applications. So I'm going to talk about one of these technologies, one of these specific technologies. Actually, I'm going to talk about a few, but I really want to talk about Elemental. And to talk about Elemental, I need to bring in some of the other technologies that we have as well. So I'm going to demonstrate SUSE's Elemental toolkit and the way in which our provisioning technology can enable a faster time to market and time to value by automating the process and reducing the time it takes to deploy your hardware and enabling IT to manage systems that live in the realm of OT. Let's take a quick look at the Rancher Management Server and get our bearings on sort of what is Rancher, how does Elemental fit into it? And then I'll come back to the slide deck in just a few minutes to look at some other things here. So this is the Rancher Management Server. I'm going to zoom in on this a little bit, I think. Let's try that again. Oh, I'm on a Mac, clicking the wrong buttons. Okay, so this is the Rancher Management Server, and you can see that I have a couple of, a few clusters. What Rancher is and does, so Rancher manages downstream Kubernetes clusters. Now, I've created a couple of clusters here, and I'm using airports in the US as samples of where we might have these edge clusters. It's not retail, but it's an example I had already, so working with it. And of course, there's a lot here that relates to how we might do things in other edge environments like retail. So cluster management we can kind of drill in a little bit more on the clusters that we have. We can explore these clusters. We also have in here something called continuous deployment. It says delivery, but this is actually continuous deployment. If continuous delivery is part of a CI/CD process that requires approval before going to the next phase, CD, continuous deployment, would be automating the deployment of the end product into a production system or into some environment without that approval. So this is really continuous deployment, and I have a single repository, which is just a simple application, and this I've told to deploy to every cluster. So if we look at our other clusters here, I can go into, for example, this Dallas-Fort Worth, and we can take a look and we can see the dashboard. We can see how much utilization is going on here. We can see how many nodes we have and what's going on with those nodes. And we can even see the workloads. And you'll see that there is one workload here in our user namespaces. So I'm just looking at user namespaces right now. There's lots of other things running in here, but this is that application which I ran from my continuous deployment system. So when the cluster joined, it actually just automatically got this software, and that's what we want at the edge, right? We shouldn't need somebody to actually go and install that because we can do it automatically these days. The other thing that I've got here, so you'll notice in my nodes here, so I've got my cluster and my nodes, and these three nodes actually were deployed using what we call Elemental. And Elemental is a toolkit that allows us to manage hardware and connect that hardware as inventory into the Rancher management system so that I can do things like build clusters onto it. So you can see here I have an inventory of machines, and right now they're sorted by name. I'm going to resort these by cluster. So let's go top down. So you can see I have a single node cluster for the JFK site, and I've got a 3-node cluster for the Dallas-Fort Worth site. And these apply to these are the physical nodes that actually would be sent to a store. What you see here, this one that says unavailable, that one we're going to come back to in a few minutes, but ultimately that is one that we're going to actually enable. So we'll come back to that in just a minute. Let's go back to our slide deck here, and let's see. So let's use a use case to better explain the value that Elemental adds to deployments. So let's consider the retail store again. Imagine you have a new rollout of hardware to over 1,000 stores across the country. If these stores have a single node, it's 1,000 nodes that you have to ship out. And if it's 3 nodes, if you're creating multi-node clusters, as we often do with Kubernetes, that would be 3,000 nodes and 1,000 clusters across the country, right? Without a technology like Elemental, you might expect tech to travel to each store, wiring and configuring each kit ready for production. So let's do some estimation, right? So if this skilled technician is expected to deploy the hardware and components and they're paid roughly 25 bucks an hour, assume maybe they can install this in half a day, let's call it 4.5 hours. And they need to do this at 1,000 stores across the country. So it's going to take about 4,500 hours to complete the install across all of these stores. This is a cost of $112,500 for this technician's wages alone. It doesn't cover, obviously, travel costs and other costs that might be incurred here, as well as when something goes wrong, we need to roll a truck or sneaker net back out to these stores and make things work again. SUSE's Elemental Toolkit, on the other hand, enables you to ship hardware which will configure itself once on the network. We can eliminate the sneaker net, ship directly to the site where the operational technologist just needs to plug it in and turn it on. So let's talk about the deployment process for getting OT in the hands of the end user without sending the skilled technician on site. The first thing we do is create a standard image. We may create more than one depending on the use case and process that works for your organization, but basically these are standard images with security and the foundation for the cloud native stack, which will eventually get added to the device. The image is configured to register with the Rancher management server, and it has a hardware security mechanism which allows us to ensure it's the device we expect. Once we have these standard images, we can image a batch of physical devices. This could be just a few, or it could be hundreds or thousands. Each of these devices has its own TPM with a unique security hash. It's a physical module on the computer and a unique serial number. And we can use that to bind the device with the appropriate configuration and application components later on. Now, we ship a device or devices to our retail stores. How many we ship, of course, depends on the enterprise approach to the solution. Any odd number of devices can be clustered for Kubernetes and will work for this use case. We do actually have in development a project to enable just 2-node clusters. In working with retail in the, I don't know, I've been working with retailers for the last 7 or 8 years on this type of project, Cloud Native at the Edge, since 2019, I guess. But we have seen a lot of retailers that have 2-node solutions in store, and it had to do with how they did disaster recovery. Maybe they had an active passive solution. And so there have been a lot of requests to do 2-node clusters. You still don't get true high availability with 2-node clusters, but we can still do quite a bit with the cloud native stack and these 2-node clusters. And we're working with Synadia on this project, the 2-node clusters, but that's for another day. Anyways, let's keep with the Kubernetes standards where you need 1 to 3 nodes for a cluster. At the store, this non-technical person needs only plug in the cables, turn on the device. This is the point we're at for our theoretical demo. I've received my device. I'm now going to plug it in and turn it on. So let me share with you for a minute let's see, I'm going to share my camera and that should come up. All right, here I am. All right, so I got here, my device has arrived. It's a NUC, okay? And I'm gonna plug this device in and turn it on. It's been prepped as you can see in the slides, right? So we're gonna plug it in here. All right, let's turn that on. All right, so now let's go back to Rancher because that thing is gonna come up over here. So, and you don't need to see me. So let's see, we'll turn that off. So what's happening now is that the device is, it's already gone through that imaging phase, and it's been, in the theoretical retail operation, this has been shipped to the retail store. I've got my operational technologist hat on, and the device has been turned on and it's coming up. And as it comes up, it's actually going to reach back out to Rancher. There we go. It became active. So essentially now that device is in the store. It's been registered. Maybe there's some additional information that's been added to uniquely identify that store. What I have done is I have marked it with the serial number. Actually, it was picked up through the configuration that we set up. And so what I'm going to do is I am going to actually create a cluster. Now the cluster creation can be asynchronous to the device. So right now the device is sitting there in the store, but it's just sitting there. It doesn't have any cool software running on it. I don't know, there's nothing. I don't see it here in my cluster management view. It doesn't exist. So what we're going to do is actually go in and create that cluster as well. So I'm going to do this using Kubernetes and kubectl. I'm going to increase the size of this for you a little bit. Let's see. Just get my bearings here. All right, there we go. All right, so what I have is another airport, this time Dulles, and it's a Kubernetes configuration. And what you can see is that I have 2 resources in it. One is what's called a machine selector, and that machine selector actually matches that serial number that we saw on the device. And then the other is a cluster API configuration, and it's binding to that. It's saying bind to the machines according to the machine selector. This is how I did the DFW and the JFKs as well. They had their own machine selectors, and in the case of DFW, where I have 3 nodes, I actually have the quantity of 3, or we could look at it, but I may have 1 control plane and 2 workers, right? Any standard Kubernetes configuration would work. Maybe some of my compute has the machine learning capabilities or something, right? Maybe I've got a video card in there, and I want to use that. And so we can make all that happen through those configuration, those images that we create. So what we're going to do is kubectl apply this. And back here okay, there it is, it popped up. And you can see it's reconciling, and it's waiting for infrastructure. So the and this could be automated in a number of different ways. It could be automated actually through our continuous deployment process, where that configuration file gets set up into a Git repo. And if it changes, say the version, so for example, here I've got DFW has an older version of Kubernetes, 125, whereas IAD and JFK came up with, I installed 127 by default. We could, through this system, remotely update the DFW Kubernetes version, and we could do that in even an infrastructure as code manner by actually setting it up in a Git repo and letting the automation handle that change. We're not going to do that today, but that is basically the idea here, is that you have control of your remote sites and the ability to manage the full stack. Now, we're back here at our retail store, and we've done step 3, sort of got shipped, it got turned on. Once the device was powered on, it phoned home to the rancher manager, which it was registered with, and it gets all the latest software updates, including the Kubernetes cluster that I just deployed and specified, and then the applications. That Hello World application is going to get put onto it once it comes up, and all of that is being deployed to that cluster. The Rancher Manager instance now keeps tabs on the device, and we can set up governance, policy, alerts related to this cluster. We also have the ability for our IT and operations people to keep a close watch on our edge solutions. In many cases, our IT will know there's an issue before the store is aware there's a problem. And new software and updates can be delivered to this site automatically. They can be done to all sites automatically on a schedule with site-specific configurations. So a lot of great things going on here to make this happen. Let's go back and just take a quick look again at our cluster that we just created. It's still updating. Let's go into our inventory again. So under OS management, I look at my inventory. I just wanted to show you, and here's our IAD. Right, so we saw the serial number here. We saw how it's connected, and when I applied the YAML, it created that cluster. The other thing I can do, and I want to show you this as well, is I'm going to show you, and it looks like I need to get back to here. So the other thing we can do is we can create a new piece of inventory. So that step, let's go back quickly here. So if we go back to slide 17, so this one, where we image the solution, let's do that. Let's take the image, and we're gonna actually do this step here where we put the image onto the machine, okay? And let's watch what happens. So again, here's my, and I want to make sure the inventory is visible when I do this. So I want to show you this script. So, oops. Okay, so I just have this script. I'm going to do this with a virtual machine. It works the same as with physical hardware. The main difference between the virtual machine and the physical device that we did is that the virtual machine I've set up to boot twice. So the physical device, imagine it was in the factory imaged and then shut down and then shipped off to the retail store, and where the retail store does essentially a second boot, and that's the time where we saw it become active. So it was sitting there unavailable, and then it became active. I could have shipped that to any number of stores, but it happened to go to this particular location, right? And that's the beauty of this, is that all the inventory is just stock. It's the same until it arrives at the store, at which point you can do the configuration and get it set up properly for that particular site. What I'm doing here is I'm using KVM and a hypervisor to create a virtual machine, and that virtual machine is going to use this elemental ISO. And that's the image that we're stamping onto the hardware. I've got another one of those images that I use for the physical devices. So same idea. So we're just going to install one here. So we're going to do, and we're just going to give it a name. So this is going to be test. This name won't show up in our Rancher Manager, but it will show up in our, so that's installing the virtual machine. That virtual machine is going to come up. The name test is going to show up in the hypervisor, which is on a separate server, so I'm not going to show you that right now. But it will show up here as inventory. Once that machine bootstraps, it actually is going to come up in the inventory of machines. It will be temporarily in the unavailable state during that first boot. Here we go. Okay, so we now have one machine that's unavailable. That is the machine I just created. Again, it's not bound to anything, but it's an available resource, and so I can keep track of my inventory as it's constructed. That then gets shipped out to a site, and we use that. Let's see. The other thing. So now that our Dulles Airport has come up, we can go in and we can take a look. We can take a look at our workloads, and we can see if our workload has come up. So it's loading the page. Let's see what happens here. We should see deployment. That is the Hello World app, because it deployed to everywhere. So it did not deploy here. Oh, maybe IAD is not ready. It's gray here. What's going on here? Looks like it's not quite up and running yet. Cluster management, take a view here. Maybe my Rancher Manager is down. So interesting thing, somebody will probably have this question. What happens if Rancher goes down? Rancher can be set up for DR. It looks like we're still configuring this server. So we'll skip to the next thing and then come back. We can, if we have time, we'll come back and take a look and see if our workload is up and running on here. So it's still bootstrapping the node and getting the cluster agent to connect. Rancher uses agents, elemental, or Rancher and the continuous deployment system both use types of agents to communicate with the downstream cluster. That downstream cluster actually has to call back. If Rancher goes out, it is possible to have remote access to your clusters. We would ask you to work with consulting or professional services to decide the right way to do that for you, because you don't want to expose clusters unnecessarily to the network, to the internet, or to the public, right? But also Rancher has the ability to be backed up and a DR site set up, so you can recover it as well should Rancher go out. All right, so let's take another look back at our deck here. And let's talk about some of the ancillary components. Not that one. Let's go to here. All right, so one of the things that I'm not going to demo today, but that is part of the retail solution is the use of Aukri. Aukri was developed originally by Deus Labs. It became part of the CNCF and an incubated project. It was acquired by Microsoft and is now an open source project under Microsoft's governance, essentially. It enables us to pull in leaf devices. Leaf devices, of course, being that tiny edge. An example of a leaf device could be a CCTV camera, a scanner, a sensor. Most of these devices like this use common protocols to communicate with applications. Some are not common, but it doesn't really matter how common the protocol is. The protocols might be MQTT, Zigbee, ONVIF, right? There's a whole list of these protocols here. What Aukri does is it allows us to surface these physical devices as resources to be consumed by Kubernetes applications. So in theory, my Hello World application or whatever my app is there, Aukri makes it plug and play. So when I plug in a webcam, Aukri will automatically deploy the relevant workload to start capturing that video. So it detects the device and it says, oh, I need this workload to go with this device. The other way it can be configured is through affinity. So we can say, which of the nodes has this device and therefore deploy my application to this node. So this is a fairly generic example, but when we start looking at the sensors and actuators for manufacturing or rolling out updates to specific hardware version, the versatility of this Aukri toolkit in IoT-focused industries is really broad. This is really far-reaching and really significant. Before we end here, let's just go back and take one more look. Let's see if we can see our workload. Yep, so Dulles is back up. Let's see what happened here. We should have, and we can see our utilization, of course. We can see we just have the one node. And we can, under workloads, we can take a look. There's our Hello World application. So it has also received that. And I can show you under continuous delivery that our repository is configured to, it's going to say not in Harvester. This is actually deploying to all clusters in the workspace. But of course, I can do specific clusters or specific cluster groups, things like that. So, all right. So, whoops, let's go back to our deck. To reiterate how SUSE can accelerate your business, I've shown how we can not only deploy applications and machines, but also devices at the edge with little interaction and complication for the operational technologist and other end users at the site. SUSE accelerates edge deployments by enabling an easier way to manage edge workloads and devices. Excuse me, another drink of water here. Of course, SUSE is focused on using open standards to accelerate business decisions, meaning you're not locked into a specific vendor or architecture. Everything SUSE produces, all our products are open source. In fact, we have acquired companies with private IP, closed source code, and we turn that into open source code. All of what I've shown you today is 100% open source. It can improve the agility of your business by removing key blockers or wasting time. You can reach out to SUSE account executive to learn more about how we can accelerate your business at your pace. Thank you all for coming. I do want to answer questions. So let's have a look at what kind of questions we have today.
Doesn't look like we have any questions that came in.
All right. Not a problem. So one question that I get often about Edge and particularly about Elemental is whether it can be used with virtual machines. And the answer is yes. And we actually have customers using it in other people's data centers. So their edge, this one particular customer is, they're in the healthcare business. And so they put workloads into about 7,000 different hospitals. And many of those hospitals, the way they operate is they have a small data center and they allow their vendors to put either a server or into the data center, or they ask them to use a virtual machine on some system that the vendor owns. So in this case, the vendor has 7,000 hospital customers, and they use virtual machines in Elemental. And what they do is they send the equivalent of, in VMware, it's an OVA. Essentially, it's a package. It's a virtual machine package that has all the components that the operator in the hospital data center needs to basically turn that virtual machine on and do exactly what we saw here today, which is to have it come up and register itself with this vendor's rancher management server, in which they deploy some software automatically to every cluster, and to other sites they deploy specifics. If you know much about the hospital industry, you know that there's multiple layers of regulation, everything from local and state regulation to federal regulation. And so every hospital has sort of a unique set of attributes and considerations when running software in those environments. And they're able to do that using this edge stack. So that's one of the questions we often get. Happy to answer other questions if you have them. Love to hear about your use cases and where you're going, what brought you to this today. Give you a couple more minutes to put a question in, and we'll see what comes up. All right, while we're waiting here, let's see. I'm going to go in and describe a couple more things in the Rancher Manager environment. So here we go. We've got a couple questions coming in. Is there a limit to how many VMs can run on top of SUSE Edge / ATIP? Just limited to hardware capability. So yeah, so the number of VMs would be relative to, so there's a couple of things here. So, and this is, I think, partly, excuse me, let me grab some more water. Yeah, so Elijah asked if there is a limit to how many VMs can run on top of SUSE Edge / ATIP. There's of course a limit to that the hypervisor may have. There would be a limit to, of course, the physical resources, and that's really, the hard limit is what size VMs are you running, and how many can you fit into the server that you're clustering your hypervisor with. But the other question, the other part of this is, what's the limit within the Rancher management system? How many maybe Kubernetes clusters can I have downstream? And there is a limit. It will depend on how many I don't want to say master nodes, but that's the word that's coming to my head. The term is control plane. It used to be, we used to call control plane plus data plane master nodes. We've tried to move to, and I don't mean just SUSE, I mean the industry has tried to move to the term control plane to refer to the combination of control plane and data plane combined. Depending on how many control plane nodes you have in your rancher manager may affect the number of nodes that you can have, the number of downstream clusters you can have. It can also be impacted by the number of resources within each cluster that rancher is managing. We are working on a solution to explore so sort of a manager of managers, because a lot of times we get into geolocation where you have multiple rancher managers. We also have something in the edge stack, which I didn't talk at all about today, called SUSE Manager. SUSE Manager manages specific, it can manage the operating systems. One thing I didn't talk about today is that through Rancher, we actually can update not just the software, not just the Kubernetes cluster. I mentioned those things. We can also manage the operating system. So if you need a kernel patch or some sort of patching on your operating system, that also can be done through this edge solution. All right, thank you for that question. Paul asked a question, could a tiny edge device be a credit card reader? Yes. In fact, we are working on a kiosk model. So in some of the edge scenarios, of course, there is a computer in a box with a monitor. Maybe it's got a keyboard, maybe it's just a touch screen. We have a solution in progress, and we're working with somebody, a customer right now, to develop that out. They use these fingerprint readers, but really any type of hardware that you might attach to a USB serial port, even things that might connect to I2C or SPI protocol, right? All those things can be surfaced up as tiny edge and be accessed through your Kubernetes resources, your Kubernetes clusters. Another question, the minimum and maximum hardware suggested for the edge. So minimum would be a single node. Obviously, you're not going to do any compute without a single node. Ideally, you might have 3 nodes. This proves challenging for a lot of reasons. I mentioned the 2-node use case, but also it proves challenging in situations where the retail business is really, if it's a pizza business, right? The goal is to make more pizzas. The goal is not to have technology be there or get in the way in any way. And they often are not designed to have these systems in the stores. Some of these stores have been around for tens of years, right? And so this equipment ends up being put on a back shelf in a closet under the manager's desk, right? We see all these crazy scenarios. So if you can get 3 servers, 3 or more as an odd number, into a retail outlet or into an edge scenario, then you can take advantage of Kubernetes high availability. There can be other advantages to that as well. Things like the ability to take out a single node and then have the system still be running. Of course, that's high availability, but there might be other things having to do with replacement in a retail store. Say one of the nodes goes out, or maybe you want to scale it up, maybe they're doing more business. It can simplify that process to have multi-node clusters in place, but it is not a requirement. And we can upgrade the nodes very quickly and even upgrade the Kubernetes on a single node without downtime to the applications running underneath it. So thanks for your questions. And I hope that you got some value out of this today. And I look forward to maybe hearing from you all sometime in the future as you develop out your edge plans and take a look at SUSE Edge Stack. Thank you.